Hi students, this is a question number 1 from the May 2025 paper 2 time zone 2. Okay. So this question is about the two cards, the one card that is moving with the speed 6 meter per second and the other card which is at rest right now. So the card X collides with the Y, and when it collides with the Y during this collision, which I will show you the different phases of collision, okay, uh the force is variable. That force which is exerted by x on y and y on x, that force is variable. Why? Because you see from the velocity time graph, this graph shows us that the acceleration is changing because this is a curved graph, right? Anyways, after the collision, what will happen? The both cars will be moving, right, either opposite in opposite direction or in a same direction. We will see from the graph their collision lasted for 40 milliseconds, and we have to show that their collision is elastic. Okay, well, I will come to this question later, but let me show you first of all how is what was happening when they collided with each other. Okay, so right now you can say, uh, just before the collision, you see this spring is in its normal form. Okay, but what will happen when it will hit the other, right? So the spring will compress, right? And when the spring is compressed maximum, and then the spring will release like this, and finally when the spring is completely released, at that moment both cards are now separated, and they both will be moving in opposite direction, which we see here from this graph. Okay, so during this, at one point, the force will be maximum, which I will show you with the help of graph, and then this force will decrease. Okay, so the collision lasted for 40 millisecond is the time of the collision. Okay, students, anyways, look at this. This is a speed of the x, right? You can call it ux. Okay, because this is speed before the collision, and this is a speed after the collision of the y. So it means that the cart y will be moving with what speed? It is moving with 4 meter per second, whereas the cart x will be moving backward with what speed? That is negative 2 velocity, negative 2 meter per second. So remember this thing, that during this collision, since there is a no external force applied, so that's why you can say that there is a no change in momentum of a system, right? So it means that the delta p of the system is zero. It means that the momentum is conserved. But what about the energies, right? So this is our, in fact, the first question. We have to prove the energy, because if the collision is elastic, then it means that the total energy, the sum of all energies before the collision, is equals to the sum of all energies after the collision. So if these two sides are not equal, it means that some energy was surely lost and the collision is inelastic. Okay, so let us write equation. So 1 over 2 mx ux square. This is the kinetic energy of the card x before the collision, plus 1 over 2 my uy square. This is the kinetic energy of the card y before the collision, should be equals to 1 over 2 mx uh, vx square. So I'm using the letter v for the final velocity, and 1 over 2 my vy square. Okay, so let us see. Don't you think this factor is zero? Because the card y was already at rest before the collision. It was stationary, right? And so let us put the values. 1 over 2. The card X have a mass 3 kilograms and its speed was 6 meter per second square, 36. And 1 over 2, 3. After the collision, the card X have a velocity negative 2 meter per second. So that is negative 2 square plus 1 over 2 into the card Y have a mass 6 kg. So 6 into the final velocity is 4, positive 4, right? Okay, so it is 3 times 36 over 2, right? Is equals to 4 times 3 is 12, 12 over 2 plus, uh you can cancel out So it is 3 times 16. Okay. So that should be 18, and 3 times 18 is 54 joule is equals to 6 joules plus 48 joules. So finally, you know that both sides have the same energy. So it means that it is verified that the total energy before the collision is equal to the total energy after collision. So hence this collision was elastic. Okay, now our next question. So determine the magnitude of average force exerted on y. Okay, so dear students, you see here that this is a x and y, right? So during the collision, the force is variable, but that is variable for both of the cards, and it is changing by an equal amount for both of the cards, because according to the Newton's third law, you know that the force exerted on the y, we can write it x on y, and this is the force exerted, equal amount of the force exerted by y on x. So if you have to find out the average force exerted on y, because why they use the word average, because this force is increasing and then this is decreasing. Let me show you. So students, we are taking velocity on the y-axis and we are taking the time on the x-axis, right? So right now I'm just showing you the graph for the one card, which you know that this is a card y. Okay, so how its velocity is changing at this point. By the way, if you draw the gradient, sorry, if you draw the tangent line, and at this point the tangent line is less steep, in the same manner at this point the tangent line is less steep. So you know very well that the gradient of the velocity time graph is none other than the acceleration, right? So that is delta vy over delta d. So this is how the acceleration is changing, right? So acceleration is 0 at this moment, and you see that this line is becoming more steep. This line is maximum steep at this point, which means um, at this time, by the way, acceleration is maximum, all right? And then at this time acceleration is 0 because the card is now with constant velocity 4 meter per second. I'm talking about the card y, okay, after the collision. So mean to say, if acceleration is increasing like this and it is not negative during this, okay, so let me show you the force time graph, by the way. So in the same manner, if I draw the force time graph, you know the force is directly proportional to acceleration. So if the acceleration is increasing from 0 and reaching to its maximum value, so it means the force is also increasing from 0 and reaching to its some maximum value and then decreasing like this. And I'm drawing this graph for the card y, remember, okay? Because the force on the card y is rightward, which is positive, whereas the force on x is leftward, which will be negative. So for the x, if I have to draw the graph, then it will be exactly similar but below the x-axis, right? This is all for just clearing the concept. If you understand the graph, you can easily understand the question and give the answer accordingly. Okay. Now this is, dear students, the maximum force. Although they have not asked about the maximum force, right? But if you have to find out, then you need to find out acceleration at this point, at this time, instantaneous acceleration, and multiply it with the mass of y. That will be the maximum force. What they are in fact asking from us is the average force, right? So average force, don't you think will tell us the what is a total change in the velocity of the y with respect to what is the total change in the time during the collision, all right? So it means that, dear students, if I have to find out the average force, that will be equals to none other than may, okay? So it should be my into delta vy over delta t. All right. So you know very well that what is a change in velocity. So the mass of y, dear students, is 6 kilograms, right? And the change in velocity, final velocity is 4, initial velocity is 0, and the time of collision is 0.030, because that was 30 millisecond, I guess, right? So it was 30 millisecond. Okay. Yes. So you have to multiply it. That will be the average force. I'm sorry, it is mistaken. This is 40 milliseconds. So here you should write 0.040. Okay, so it should be 24 divided by 40 over 1000. So you can take here, and dear students, it will be 600 Newton. This is the average force. Now, it's not a peak force, it's not a maximum force, dear students. It is the 600 Newton is right now at this point. Okay. So, in the same manner, the average force exerted on X is also negative 600 Newton. Right. So, this is 600 Newton. Now, the next question is average power delivered to the Y. Okay, when you have got the average force, you can find out the average power as well, right? In fact, we have two methods, right? The one method is, because you know that the velocity for the Y is changing from 0 meter per second to the 4 meter per second, right? For the Y, it was initially stationary, right? So it have a no velocity, but it increased to the 4. So it is not increasing uniformly, right? That's why when you will find out the average power, right, which is equals to the average force multiplied by the average velocity, which is u plus v over 2, right? So we will take the average velocity because velocity is not increasing uniformly. So it should be 600 times 0 plus 6 over 2, right? Sorry, 4 over 2. So that should be equals to 1200 watt is the average power. Okay, let us discuss about the other method, right? The other method talk about, we can also calculate it from the general equation of the power, right? So what is a power? How do we define the power? We say it is the rate at which work is done. Clear? So how much work is done? Work was done because the force was applied on the Y, and the cart Y moved in the direction of force. So it means that was a positive work, right? So if there is a positive work, it means that there must be a gain of energy due to this collision. So I will write here gain in kinetic energy of Y over the time of collision, right? There was no any other energy that was gained during this work done. So that's why this is just this gain energy, right? So final energy of Y minus initial energy of Y over time taken. So since it was at rest, this energy is 0, and you can plug the values, you will get the same answer. So students, this is the same answer, that is 1200 watt. This is another method. Okay, now let's proceed to the next question, which says elastic energy stored in a spring at the 30 milliseconds, right? So if you remember in the beginning, I told you that how the spring first compresses, right? A little bit, and then it stretches. So when it stretches, during this, it applies force, as well as the force was applied during compression, but that force was variable. So, but the elastic potential energy was storing during this whole process, okay, because the work was done, right? So, so this potential energy then later on converts into the kinetic energy, okay, kinetic energy of both. Let us see this graph, right at 30 millisecond, 30 millisecond, both cards were moving, okay, and they have the velocity, and in fact they have a velocity positive, right? So which means that both cards are moving to the right. Okay, so don't you think when the both cards have a velocity, okay, so they possess the kinetic energy, because kinetic energy is due to the motion, right? So not only they have the kinetic energy, right? So I can say, so right now I can say the total energy right at this moment of time, that time t is equal to 30 millisecond. What is the total energy right at this moment? We can say it is 1 over 2 mx vx square plus 1 over 2 my vy square. This is the kinetic energy of both cards, plus important thing, potential energy. All right, this sum of this total energy right at this moment cannot change. If you apply the law of conservation of energy, it should be equals to 54 joule. If you remember, we had calculated this energy in the first question, right? So if you find their kinetic energies during this collision, Okay, you can find the potential energy. So 54 is equals to 1 over 2. So I'm just plugging the values. So see here, I have put the 2, velocity 2, plus 1 over 2, the mass of y is 6, and its velocity is also 2, because these two graphs intersect at this point. So 2 square plus the potential energy. So 54 is equals to 12 over 2, that is 6 joules, plus 3 times 4, that is 12, plus the potential energy. So finally the potential energy right at this point, 36 joule. So this is a potential energy that is also changing, okay, during this time, the whole time of collision.